So now we're going to look at some special product patterns, ways to multiply binomials that fit a special pattern. Okay. So we got two special product patterns, the sum and difference pattern or the square of a binomial pattern. So sum and difference pattern means that I have two binomials that are the exact same except for one has a addition in the middle, the other one has a subtraction in the middle. So a plus b times a minus b. So we could FOIL that, or we can just know that if I take the first term and square it, and then subtract from that the second term squared, that's the same thing as multiplying it out and FOILing it. And then we have a square of a binomial pattern, which is if I have two terms that are added squared, or if I have two terms that are subtracted squared. The pattern for a plus b squared is a squared plus 2 times a times b plus b squared. So square the first term, then I take the two terms, multiply them together, and then multiply that by 2 or double it. And then take the last term and I square it. Very similar if it's a minus b squared. The only difference to the pattern is that we have a subtraction after the a squared instead of an addition. So using these patterns, 5t minus 2 times 5t plus 2. So I've got a minus and a plus, 5t and 2, 5t and 2. So I want to end up with a squared minus b squared. So my a term is 5t. I'm going to square that. My b term is the 2. So 5t squared minus 2 squared, which 5 squared, 5 times 5 is 25. T is just going to become t squared, and then minus 2 squared, which is 4. Same thing if I do 3b minus 5 times 3b plus 5, minus and plus, but all the first terms are the same, the last terms are the same. So looking for a squared minus b squared. The a term is 3b. I'm going to square that. Minus the b term, the last term, which is 5 squared. So 3 times 3, 3 squared is 9. So 9b squared. And then minus 5 squared, which is 25. So that's a sum and difference pattern. Now to find the products of a square binomial, this one's 7a plus 2 squared. So we're using the first pattern, which is going to give us a squared plus 2ab plus b squared. So a and b. So take the a, 7a, square that. Going to add to that 2 times the a term, which is 7a, times the b term, which is 2. And then add to that the b term squared, which is 2 squared. 7 squared. So I ended up with 49a squared. 2 times 7 is 14. 14 times 2 be 28. And there's just the a there, so 28a. And then 2 squared. 2 times 2 is 4. All right, so then the next one is 2p minus 5q squared. So it's got a subtraction in between the two terms, so we're using this pattern, a squared minus 2ab plus b squared. So 2p is the A, 5q is the B, so 2p squared minus 2 times A, which is 2p, times B, which is 5q. And when we do these, we're not paying attention to the signs here, so we're not writing it down as negative 5q. It's just that term after the subtraction, which is 5q. And then plus 5q squared, the b term squared. So 2 squared, it's going to be 4. P squared is p squared. Negative 2 times 2 is negative 4. And negative 4 times 5, negative 20. And then we have two variables, p and q. We can't multiply them together, so they're just going to sit there side by side. So negative 20 pq. And then 5q squared. 5 squared is 25. Q squared is just q squared. So 4p squared minus 20pq plus 25q squared. So those are our special product patterns.